What is conservation of energy? The law of conservation of energy states that energy can neither be created or destroyed. But what does that mean? It means that in a system, the sum of all energy, or the total energy, is always constant. There are many different types of energy, such as potential energy, kinetic energy, heat energy, light energy, sound energy, friction energy, and spring energy, just to name a few. The two main types of energy that we will be focusing on are gravitational potential energy and kinetic energy. The symbols for these two types of energy are as follows. For potential energy, there is Eg, Pe, Ep, or Ge. And for kinetic energy, there's Ek and Ke. The equation for potential energy is Eg equals mass times acceleration due to gravity times height. And the equation for kinetic energy is Ek equals 1/2 mass times velocity squared. Next, let's take a look at an example of how this type of energy can be used. For example, a Ferris wheel. If this Ferris wheel is an ideal system with no friction and 100% efficiency, then the only types of energy at play are potential energy and kinetic energy, and the total energy is always constant. Here, here, and here. At the top, or the higher you get off the ground, the more potential energy you have. The closer you get to the ground, the more kinetic energy you have. But you will always have both kinetic and potential energy because the wheel is always moving and it never touches the ground. This graph shows one oscillation of a Ferris wheel and the conservation of energy if the system were a perfect system. Even though Ek and Eg are always changing, Et always stays the same. But what if a system is not 100% efficient? If a system is not 100% efficient, that means that energy is lost, but that doesn't mean that it just disappears. It means that energy changes, forms, it transforms. Energy is usually lost to heat, friction, or sound. If you want to find how much energy is lost, there are two ways that it can be found. One is by calculating percent efficiency, and the second is by isolating for energy lost. The equation for percent efficiency is final energy divided by the initial energy times 100%. The value you get tells you how much of the original energy is left. To isolate for E lost, you must know Eg1, Eg2, Ek1, and Ek2. You start out by setting Et1 equal to Et2, and then you sub in the next amounts of energy. Eg1 plus Ek1 plus Eg2 plus Ek2 plus E lost. You then move the variables and isolate for E, with E lost on one side and Eg1, Ek1, Eg2, and Ek2 on the other side. So the moral of the story is, physics is sticky, and ET is constant.